Hello good people, I'm going to talk about points of interest on a graph. By points of interest, I'm referring to the x and y intercepts as well as the point of intersection. What they represent is contextual. It depends on the given scenario. Suppose that we have a patient that is hooked up to a bag of saline solution. The solution is being delivered at a constant rate. As time passes, the volume within the bag decreases. If we were to plot the volume of the saline solution in a bag versus time, it may look something like this. What do the y and x-intercepts represent in this case? The y-intercept occurs at time 0. This is the point in time when the bag is full. And in this particular case, it would appear that the bag is full when it contains 800 milliliters. So the complete coordinate for the y-intercept would be 0, 800. The x-intercept, on the other hand, represents the time when the bag is empty. And in this case, it would seem as though it would take 80 minutes for the bag to become empty. The full coordinate for the x-intercept is 80, 0. Suppose that there is a second bag of saline solution, and when we plot its volume versus time, we end up with the following line. Once again, we have an x and a y-intercept. The y-intercept is at time 0, and again, this is the moment in time when the bag is full. And the coordinate for the y-intercept in this case is 0, 600. So this second bag of saline is smaller. It contains less volume, only 600 milliliters. The x-intercept represents a point in time when the bag is empty, and the complete coordinate is 100, 0. This means that the second bag will be empty after 100 minutes. What about the point of intersection? This, recall, is a point of commonality. And in this scenario, this represents a point in time where both bags will contain the same volume. According to the graph, after 50 minutes, both bags will contain 300 milliliters. This means that the point of intersection is at 50, 300. Let me bring in another example. Suppose that we have a runner wearing orange who is running at 5.00 meters per second. If we were to plot their run distance versus time, we would end up with a line like this. The y-intercept of the orange line represents the starting position of the orange runner, and the complete coordinate is 0, 0. All right, but suppose that there is a second blue runner. They are running at a slower pace, at 1.67 meters per second. However, they are running ahead of the orange runner. And if we were to represent their run with a line, it may look something like this. Its y-intercept represents their starting position, and it happens to be 100 meters ahead of the orange runner. And this is why when we plot their line, it begins at 100 on the y-axis. What about the point where these two lines meet? Well, that is the point of intersection. In this case, it represents a point in time when the orange runner catches up with the blue runner. And according to this graph, it seems to happen after 30 seconds and 150 meters. And so the coordinate for the point of intersection would be 30, 150. Let me add a third runner in green. Now this third runner is running at a speed of 3.33 meters per second, but they are starting 50 meters behind the orange runner. How do we represent that on this graph? Well, we need to extend our y-axis into the negative territory, because we need to represent 50 meters behind the orange runner. That means that with respect to them, that would be at minus 50 meters. Plotting the run time for the green runner would give us the following line. Note that the y-intercept of the green line is the starting position of the green runner with respect to the orange runner. and the coordinate would be 0, -50. What about the x-intercept of the green line? This represents a point in time when the green runner reaches the starting position of the orange runner, and it seems to be after 15 seconds. And so the coordinate for the x-intercept of the green line is 15, 0. We also have another point of intersection. This time, the point of intersection for the blue and green lines. This point of intersection represents the point in time when the green runner catches up to the blue runner. Let me look at one more example. Suppose that there are two services that are offering encrypted data storage. The service in orange has a 50 cents subscription fee. After that, they charge 20 cents per gigabyte. The black service has a 300 cents subscription fee, but after that, they charge only 10 cents per gigabyte. At what point is the cost of the two services equal? Or even better, at what point is one service cheaper than the other? If we were to represent this in a graphical format, the line for the orange service would start at 50, because that is their subscription fee that we have to pay regardless of how many gigabytes we store. After that, the price increases at a rate of 20 cents per gigabyte. And so the orange line would look something like this. The line for the black service would begin at 300. That is because 300 cents is their subscription fee. After that, we pay 10 cents per gigabyte. And so the black line would look something like this. The point of intersection represents a point where the cost is equal. And based on this graph, the point of intersection appears to be at 25, 550. This means that after we have uploaded 25 gigabytes, both services would cost 550 cents. After that, the black service becomes cheaper. Keep in mind that every graph tells a story, and the points of interest, that is to say, the y and x-intercept and point of intersection, convey contextual information. It always depends on the scenario we are looking at. That being said, generally speaking, the y-intercept tends to represent the starting point, while the point of intersection represents a point where our given examples are equal. That is all for now, and I will see you on the flip side.